Okay, I'm going to give you another minute or two to work on this warm-up. All right, let's take a look at this warm-up. The inverse function of f of x equals 2 to the x plus 1. When we are finding an inverse, what do we do? Just in general, when we are finding an inverse. Switch the y and the x. So we're going to have x equals 2 to the y plus 1. We're trying to solve for y. So we're going to subtract 1 from both sides. So we have x minus 1 equals 2 to the y power. When you are trying to solve for a power, that's why we use logs. So turn this into a log. What would it be? Base 2 of x minus 1 equals y.
Why is the x minus 1 in parentheses?
Because this is the whole, this is all the argument. So we subtracted 1, and then we rewrote this as a log.
So for how come on the original function it's not 2 to the power of x plus 1?
Because those aren't inverses. So f inverse of x is log base 2 of x minus 1. Questions on that? All right, what did you get for number 2? Good. Anyone need help on that one? Okay. Let's look at 3. Should have had log base 5 of x squared equals log base 5 of 900. So from here, if our bases are the same on 2 logs, we can set the arguments equal. So x squared equals 900. When we take the square root, what do we have to remember? Yes, this is plus or minus 30. That's not our final answer. And let me talk to you about why. Picture this equation right here. Y equals log base 5 of x. Tell me what the graph of log base 5 of x looks like.
Start from x equals 0.
Doesn't start there. What is x equals 0? Good. There's a vertical asymptote at x equals 0. A point at 1, 0. My base is greater than 1. So we have a shape like that. That's the shape of our basic parent function, log base 5 of x. What is the domain of this graph? Is 0 included or not? Okay. Would you agree that the domain represents my x values? Yes? Yeah. Okay. Where is the x in our original parent function equation? It's the argument. Yeah. X is the argument. So what that means is that this domain is talking about your argument. Your argument must be greater than 0. Has to fall in that realm because of what the graph looks like. So my answer to number 3 on my warm-up is not plus or minus 30. What is it? 30. Just positive 30. So this leads us into our notes for today, solving exponential and log equations. And the really important part that you need to make sure you've got down is that your argument of your log must always be positive. Can it be 0? No, it has to be positive. Yes, sir.
Are we going to use calculated range instead?
All right. So this is 8.6. Here's our first problem. Log of 50 plus log of x over 2 is equal to 2. This is mainly review just with a little addition, making sure we are checking for extraneous solutions. We've got to be sure we're not picking a solution that makes any of our arguments not positive. So what's the first thing we're going to do here on number 1? Okay, combine the left-hand side. So this is going to be log of 50 times x over 2 is equal to 2. What is 50 times x over 2? So this is log of 25x equals 2. What am I going to do from here?
Change your 2 to log of 100.
Okay, change it to an exponential equation. Remember that you've got a base of 10 implied here. So this is 10 squared equals 25x. 10 squared? 100. So what is x? X is 4. If you plug x back in for x equals 4, are you going to have any arguments that are not positive? No, it's still going to be positive, so that's our solution. Blake?
Could you change 2 to log base 10 of 100?
Sure. Other questions? All right, let's look at number 2. Log base 3 of x minus 4 plus log base 3 of x plus 4 is equal to 2. What should we do first?
Combine.
Good. Combine the left-hand side. What is x minus 4 times x plus 4? Squared minus 16. Equals 2. Rewrite this as an exponential. What's that going to be? 3 squared equals x squared minus 16. So 9 equals x squared minus 16. If we add 16 to both sides, we're going to get 25 as x squared. We take the square root, we get plus or minus 5. Do both of those work?
No.
Which one does not? Why?
Because the argument always has to be positive.
The argument has to be positive. Good. It's not that x has to be positive. So the argument has to be positive. So when you plug in negative 5 up here, you're going to get negative 5 minus 4, which is a negative 9, which does not work. Negative 5 plus 4 is a negative 1, which does not work. So my solution here is just x equals 5.
Oh, so if it was like negative 3, it would work.
Correct. Everyone okay on that?
Yep.
Number 3 is log base 10 of x plus log base 10 of x minus 9 equals 1. What should we do first? Condense the left. I'm going to have log base 10 of what? Good. Is equal to 1. How would I rewrite that? Good. Rewrite it as an exponential. 10 to the first is just 10. What kind of equation are we left with? Quadratic. In order to solve quadratics, we must get our equation set equal to 0. So this is going to be 0 equals x squared minus 9x minus 10. How do we like to solve quadratics? Factor. What does this factor into? Okay. X minus 10, x plus 1. So what are our two possible solutions? 10, negative 1. Check them in your arguments. Make sure your arguments are positive. Do they both work? No. Which possible solution does not work? Negative 1. That negative 1 is extraneous. My solution is just 10. Questions on that? Well, it's not that you get negative numbers. It's that if you plug in a solution and you get a negative argument. But if none of your solutions work, then your answer would be no solution because both solutions are extraneous. All right, please try number 4. You can check your work up here as you're finishing that. Do both negative 12 and 3 work? Or sorry, 12 and negative 3, do they both work?
No.
Which one does not? Questions on number 4? Yep.
If you did it where there's a negative and both arguments of your A value are negative and then multiply together to get a positive A value.
You have to base your decision on whether an answer is extraneous or not off the very, very, very original equation. If it was ever an argument, if an argument is ever negative, then it can't work. All right, let's look at number 5. Yes, log 16. Log base 16 of x squared plus 2x equals 3/4. So ideas on my first step? All right, so change it to an exponential. 16 to the 3/4 equals x squared plus 2x. Let's talk about 16 to the 3/4. What does the 4 do? The fourth root. What's the fourth root of 16? 2, and 2 cubed? 8. All right, would you please finish this problem, please? So when you factored this, what'd you get as your two factors? X plus 4 times x minus 2, which gives me my two possible solutions as what? Okay, and what do I do from here? I test them. I don't just assume that the -1 doesn't work. I have to test them. If I plug in -4, what's -4 squared? 16 minus 8 is 8. Does -4 work?
Yes.
Yes, that is one of your solutions. How about 2?
Yes.
Yeah.
Is the positive value ever not going to work?
Could.
Good.
Because if you had x minus 5 as your argument,
Okay.
if you plugged in a 2, that's going to give you a -3, right? So you just have to check them. Yes?
Which equation are you plugging them back in?
You have to plug in your solutions to the original argument. You have to go back to this x squared plus 2x. Okay? Because these are both solutions to your equation that you solved. But it's that you have to go back and make sure that they're part of your domain restrictions. Okay? All right, let's try number 6. What do you think our first step on number 6 should be? Yeah, combine the left. Then we rewrite as an exponential. So 10 to the -1 equals x over x minus 3. What is 10 to the -1? 1/10. X over x minus 3. What should we do from here? Cross multiply. So this is going to be 10x equals x minus 3. Subtract our x. So 9x equals -3. What does x equal? -1/3. Check your original arguments. If you plug in -1/3, will you have positive arguments? No. So my answer doesn't work. So my answer is no solution. Questions on that?
Is it, have to look for each argument?
Has to work for everything, yep.
Not like.
Why is it negative?
Hmm? All right, let's look at number 7. Log base 7 of 5x plus 5 minus log base 7 of x squared minus 1 is equal to 0. My first step would be to condense the left-hand side. So I'm going to have 5x plus 5 over x squared minus 1 equals 0.
Would be factor x squared minus 1.
We can worry about factoring them in just a moment. Let's turn this into an exponential. 7 to the 0 power equals 5x plus 5 over x squared minus 1. What is 7 to the 0 power?
1.
Okay, and factor these. How does 5x plus 5 factor? What about x squared minus 1?
X plus 1 times x minus 1.
Do you notice anything that we can do?
Also,
Yeah, x plus 1's cancel. You don't have to cancel them. You'll still get the right answer as long as you are careful about checking your work. It just kind of makes your work easier. So I would cross multiply. I would get x minus 1 equals 5, so x equals 6. Check 6. Does it keep both our arguments positive? Yes. Questions on those?
Your argument is 0, it doesn't work.
Correct. Your argument cannot be 0. Think about your graph. We have an asymptote at x equals 0. All right, please try number 8.
let's say log base 5.
Log base 6 of b squared plus 2 plus log base 6 of 2 is equal to 2. Check with your neighbor when you're done. Do both plus and minus 4 work? Yes, they both work in this case. You can't just throw out a solution because it's negative. You have to plug it in and check. All right, let's look at number 9. Sorry, were there any other questions on number 8? Okay, let's look at number 9. What do you notice about number 9? You have logs on both sides. Well, we can fix that. What could we do? Yeah, just add log base 3 of x plus 5 to both sides. So now our problem is log base 3 of x plus 3 plus log base 3 of x plus 5 is equal to 1. Can we solve that? Yeah?
Yes.
Okay. You are going to finish numbers 9 and 10. Okay. When you're ready, I will come check your work and give you your homework.